Welcome dear audience, students and scholars. Here I am Dr. Amjad Ali. In this video we are going to discuss about stem and leaf display. Dear scholars, it is another important technique that is used to present quantitative data in a condensed form. So one of the main advantage of a stem and leaf display over a frequency distribution is that by preparing a stem and leaf display, we do not lose information on individual observation. A stem and leaf display is constructed only for a quantitative data. So let's see the definition of stem and leaf display. In a stem and leaf display of quantitative data, each value is divided into two portions: a stem, the first part of value, and a leaf, the last part of the value. The leaves for each stems are shown separately in a display. So let's see the empirical example. For this purpose, we have the raw data of 30 college students which gets different grades in a statistical test. So we have first score is 75, second score is 52, third score is 80 and 96, so forth. So we have to construct a stem and leaf display for these scores. So we split each score into two parts. The first part contains the first digit, which is called the stem. The second part contains the second digit, which is called the leaf. Thus, for the score of the first student, here we have 75. So 75, from the 75, 7 represent the stem and the 5 represent the leaf. So for the score of the second student, that is 52, so 5 represent stem and 2 represent the leaf. Like that, we have here in data set, we observe that our data range start from 50 to 98. So our stem started from 5, 6, 7, 8 and 9. And for leaf section, we have like that, we have 52, and from 52 we have leaf 2. So here in 52 we have 2 as a leaf and 5 as a stem, and like that we have the 75. In 75 we have leaf for 75 is 5 and the stem for 75 is 7. So we observe our data set is starting from 5 to 9 for all the scores here which students are getting in a statistical test. So create a stem and leaf display. We draw a vertical line like that, 5, 6, 7, 8 and 9, which write the stem on left side of it. So we are arranging the data in an increasing order like that, 5, 6, 7, 8 and 9. So we are making the stem and leaf like here. So if you see that we have first score is 75, we put 7 here and we put 5 here, and then our score is 52 and we put 5 here and 2 here. So then we have 80, 8 here and we put 0 here. 96, we put 9 here and 6 here. And when we have 65, we put 6 here and 5 here. So like that we are making the leaves on the basis of same stems. So the recording of these two scores in a stem and leaf display enable us to view that how much stem have leaves. So here we can understand that we have 5 as a stem, 3 other leaves are representing the fifth value. So by looking at the stem and leaf display here, we can observe that the data values are distributed. What are the range of the data? So for example, if you see that here 7 has the highest frequency, like 5, 9, 1, 2, 6, 9, 7, 1, 2, followed by the stem of 8, 9 and 6. So the leaves for each stem of the stem and leaf display can be ranked in an increasing order or decreasing order. Like that, we are arranging this data we are arranging this data 5, 0 to 7, like in previously when we are getting the information from this raw data into stem and leaf display, we are making the arrangement as it is. But when we are ranking this data, it's look like that. So as we have highlighted that one of the main advantage of stem and leaf display is that we do not lose information on individual observation. So we can rewrite the individual score of each 30 student in the stem and leaf display, and we can arrange our information in ungroup or in a rank or group order as well. So let's see another empirical example for the stem and leaf display. So we have 30 household information on a monthly rent, like first household is paying $880, and second is this and so on. So we have to construct a stem and leaf display for this raw data. So see here, each of the value in the data set contain either 3 or 4. So see here we have 3 numbers or 4 number. So most of our values have 4 digits and some has 3 digits. There is no value is available which have 2 or 1 digit or more than 4 digit value. So that's the first value which is here is 880. So the stem is here 8, and we have leaf as 80. So the stem for the entire set for this data set is somehow starting from, so somehow we have the lowest value. Let me see, the lowest value is here is 750, and no less than 750. So I think no less than 750, or there is any value which is less than 750. So here I think here 630 is also available. So where is 630? This is 630. So our leaves our stems are starting from 6, 7, 8, 9, 10, 11, 12 and 13, because we have the highest leaf here is 13. So we can solve this raw data with the help of stem and leaf display like that. We have 6 is lowest number, 7, 8, 9, 10 in an increasing order till 13. Okay, in first case we have stem 6 and 30, and 7 we have 750 as well, and 77, 75, like that we are arranged the form of this data. So sometimes a data set may contain too many stem and leaves, which each stem contain only a few leaves. In such cases we can make the stem and leaf display by grouping the stems of different classes or different numbers as well. So let's see another example for this purpose. So here we have the stem and leaf display which we prepare with the help of 25 students which spends their time on computer during 1 month. So this is prepared stem and leaf display, and we have to make the stem and leaf display of groups of stems. So to condense the given stem and leaf display, we combine the first 3 rows 0 to 2, and then 3 to 5, and then 6 to 8. We are making the classes of these different stems. So the leaves for each stem for the group are separated by a static. So let's see the solution of this is like that. We are starting our classes 0 to 2, and then 3 to 5, and then 6 to 8. So here when we write the leaves of first, and then we put the static sign for the second, and then we put the static sign for the third, and so forth. If we have the fourth number, then we put the static for the fourth as well. Thus the leaves 6 in the first row here corresponds to stem 0, and the leaf 1, 7 and 9 here correspond to stem 1, and the leaf 2 and 6 belongs to the stem 2. So likewise we have to write the leaves for the 3, and then 4, and then 5. So if a stem and leaf does not contain a leaf, like here we have a 7, so here we see that 7 does not contain a leaf, but we have to put it make the increasing order of our stem, so that's why we put 7 here, but 7 does not take any leaf. So there is no leaf for the 7, so for this we can put 2 static here. So this 2 static represent that there is a 1 stem which don't have any leaf, so that's why we put 2 static, and after that we put the leaves of others. So here 5 and 6 represent the leaves for our 8 stem. So this is all about the stem and leaf display for the quantitative data. So see you with another video. Ciao.